All right. Hi everyone. So this is sort of a last minute deal for you E-Block class. Sorry, I had something family emergency come up, and so I cannot make it to class today. But this should be a helpful sort of supplement to that. So what I'm going to do is I'm going to start the video, and then I'm going to narrate it, and I'm going to write some stuff as we do this, and then hopefully that'll help you understand how to use this solubility table that we have, that you guys all should have, that's on the back of the periodic table. Okay, so here we go. All right, so there's two flasks here. One of them has lead 2 nitrate in it. Okay, so I'm going to write that. And that's a solid, or it was a solid. And then the other one is a white solid that's also potassium iodide. Now it's a solid, but now they're actually pouring water into it. And so it is dissolving. Okay, so we're actually not going to put solid anymore, because now it's no longer a solid. Now it's dissolved in water. Now, what we're going to change that to is we're going to use this little term here called AQ. And AQ means aqueous. And that just means I took something that was a solid and I dissolved it in water. It dissolves. Okay, another word that we use in chemistry is called soluble. And again, that just means that something was able to dissolve. Soluble. Like hot chocolate powder is soluble in water. Sand is insoluble in water. It does not dissolve. Okay, so I should be able to then predict the products here of this equation. So the outers and the inners are going to go together. So I'm going to get lead, iodide. Oh, and now you can see what's happening here. We get a precipitate that's formed. If you remember that, precipitate, a solid was formed from those two liquids mixing together. If the inner two ions come together, we get potassium nitrate. Okay. Now what he's showing you right here is that was after about an hour. All that yellow solid precipitate sort of fell to the bottom of the flask. Let me go back to that. Okay, so you can see that there clearly was a precipitate that was formed. A solid was formed. So now our job is to figure out, well, which one of these two products is the solid? Which one is the precipitate? So I'm glad you asked that question, because now we're going to go over to your solubility rules table, which should be on the back of your periodic table. And on yours, I think I hand wrote in AQ right here, just to remind you that anything that is soluble, we're going to get the symbol AQ. Anything that is insoluble, that does not dissolve, we're going to give it the symbol S for solid. Okay, so we have solid and we have aqueous. And the other thing I'll put in here is DR. You guys can write this in too. Double replacement only. So for solubility rules, we're only going to use the solubility rules with double replacement reactions. Okay, activity series over here, we're only going to use this with single replacement reactions. So this box right here, just ignore it for right now. That's only for single replacement reactions. But everything else we're going to use for double replacement reactions. Okay, so if we go back to this, now I want to be able to figure this out. What is my precipitate? So I'm going to look at the negative part of this compound and the negative part of that compound. So potassium nitrate. So I want to go to my solubility chart and I want to look up nitrates. Okay, and it tells me right here, it says that, oh, what's going on? Let's see if that works. There we go. So it's telling me that nitrates, it says all nitrates are soluble. Okay, so that means I'm going to use the AQ indication for my nitrate. So I come back over here, potassium nitrate. I'm going to say that that is AQ, aqueous, because all nitrates are soluble. Now I'm going to look up I, or iodine. So if I come back over here, iodine is right here. And it says all iodides are also soluble. So normally I'd put an AQ there. However, there are some exceptions. And it turns out that lead 2 iodide is actually one of the exceptions. So this means that this is not soluble, but this is insoluble because it's an exception. All right, so all iodides are soluble except this one, which is insoluble. So I'm going to be using the symbol S for this because lead 2 iodide is insoluble. And that makes sense because I saw a solid form. So that means that this is going to be my solid. So we can actually predict what the precipitate will be just by using those solubility rules. And then we can do the experiment and see, okay, I did actually see that yellow solid form. The only thing I didn't do was balance this equation. So you guys are like, hey, you forgot to balance that. You are right. So I'm going to put a 2 there and a 2 right there. And now it should be balanced. Okay. So that's basically what we're going to be doing on your homework. Okay. And now your homework, I just want to reiterate what we're doing for homework. There's a front and a back side to this. I only want you to do the front side for Wednesday. So all you're going to do is 1, 2, and 3. That's it for Wednesday. And it's going to be pretty simple because all you need to do is step 1. That's it. You don't have to do 2, 3, 4, and 5 yet. We're just going to do 1 for Wednesday. So all I'm asking you to do is write out the balanced equation for this, predict the products, and then use your solubility rules to figure out what the physical states are for each of those. So they're either going to be aqueous or they're going to be a solid.